Raja,
Ya,
okay, macam mana Okay, I got the apa ni, the slide to show. So daily booking, you just can stop sharing. Meanwhile, we wait for the others. I will show the supaya tak berbunyi.
Oh.
Sebab dia host kan. Sebab bila berbunyi tu dia agak ganggu. Terus biar ada ke?
Ya, dengar.
Pergi dekat bahagian preferences dekat Webex meeting tu. Nanti dia ada dekat preferences tu dia ada participants join the meeting tu. Unclick kan benda tu.
Sekejap dekat Webex. Kenapa participant tak boleh masuk
Bukan, dia berbunyi. Dia ada bunyi yang submarine tu.
Dekat preference.
Just pergi dekat yang kan dia ada sound kan.
Audio and
alerts
video.
Tu. Alerts. Alerts dia tu the participants joins the meeting tu. Untick benda tu.
Alert. Tak jumpa lah aku semua.
Dekat Webex meeting. Tak jumpa.
Tukar je. Tukar role. Kak Husna jadi host. Kak Husna. Husna jadi host.
Husna ambil terus.
Kena ni lah kan.
Entry and exit ke?
Entry and exit.
Tukar kepada?
Bukan tukar kepada, dia ada button click unclick tu. You just unclick dia supaya dia tak keluar bunyi. Jadi siapa-siapa masuk tak adalah dia bunyi tu je.
No tone lah macam tu.
Tone dia tu. Kita just unclick dia je.
Kak Arbi pilih no tone lah
no tone.
Okay, done.
Okay, thank you.
Lagi save ke? Oh tak save.
Okay, I think it's already 10 o'clock. I think we have to start now. Alright, is it okay, Dr. Ruzi and Dr. Rubia? Can I start now?
Okay, yes, please, Amiza.
So I think, have you recorded? Have anybody record this session? Okay. I hope it's all been done. Alright, okay. Bismillahirrahmanirrahim. Assalamualaikum and greetings to all attendees to our industrial talk. Okay, so this industrial talk is organized by Ubiquitous Broadband Access Network, abbreviation UBAN, and IEEE Instrumentation and Measurement Society Malaysian Chapter, abbreviated as RMS. And the title of this talk is NB-IoT over 5G technologies. Okay, so as you all know, NB-IoT is one of the wireless communication technologies used for sensory data communications apart from LoRa and Sigfox. So NB-IoT has been specified and introduced by 3GPP, which is an organization that have developed the LTE and 5G. And this talk will introduce the NB-IoT features that will run over 5G technologies. And we hope that this talk will enlighten all attendees with new information and outlook, and also hopefully new techniques, to have NB-IoT in 5G environment. Okay, let me introduce to our invited speaker. Okay, technologist Raja Muhalli Hashim is currently a resident engineer with Sandvine Technologies Malaysia Sdn Bhd. He is an alumni of UTM and has more than 50 years of experience in telco, enterprise, and IT. He has huge experience in various fields, namely networking, 4G, 5G, virtualization, and cloud network security. He has worked in Metaswitch, which is a Microsoft company, and previously worked for Nokia and Huawei. Okay, for your information, this talk will will be for 45 minutes, whereby the speaker will talk for 45 minutes, and this will be followed by 15 minutes Q&A. Okay, we would like to request the cooperation of all attendees to post or write your questions in the chat. I understand we have an FB live at the same time, so please put up your questions in the comment of the live. Okay, e-certificate will be given to all attendees, of which the link to register will be given in the chat box or and also in the comments of the FB live. Please do so before the talk ends. Later, okay, after the Q&A, we will have a group photo session of all attendees and speaker before we end this talk. Without further delay, I welcome technologist Raja Muhalli. The floor is yours.
Okay, thank you, PM Liza. Okay, Assalamualaikum warahmatullahi wabarakatuh. Syukur Alhamdulillah. Actually, thanks a lot to UTM, Urban, and IEEE because inviting me for this talk. This topic actually that I proposed to earlier to UTM NB-IoT over 5G technologies. Actually, for this one, there are two main topics that I will elaborate in details. One is on the access part on the NB-IoT, narrowband Internet of Things, 5G technology more on the core networks, 5GC. Okay, this is a topic that I will present for this morning.
Can you share your slide?
I already, wait. Oh, sorry.
Okay.
Okay, sorry.
Okay. All right.
Okay, this is a topic that I will present for this morning. Mobile architecture. Actually, first I will introduce how the mobile architecture for the 4G and 5G. Then I will go to the NB-IoT. Then later, this one is a core network, 5G core next generations, how the high level and use case for this. And then there are another backup slide that contains on the additional slides and also reference for this topic. Okay. By the way, before we start for this presentation, allow me to introduce about myself. Actually, I'm a UTM product. Actually, I study in UTM, diploma in electronic engineering, 1998 to 2001. Actually, one of my lecturer here is a PM Liza, taught me about electronic communications. And I'm further my study, 2002 to 2005, UTM Skudai in the electrical engineering, majoring in electronic. And then for the executive summaries that highlight by PM Liza, actually I'm a senior specialist over 60 years of experience in the telecommunication or in the IT industry. This include on the network, mobile data architecture, virtual EPC or 5G technologies, and also I cover for the voice, IMS, TAS, and then for the SDN, network security, DPI. So these are my skill sets for the 16 years that I developed myself. Actually, I know the system, I know the network, and then I know the security, and then I know the programmings, and then I also involved for the database. And also the main thing is we can, before we develop for something, we should read about the 3GPP, about the release, the version release on the technologies. Okay, this is my career flow. Actually, 2001, actually, I did my practical training in Sapura. This one, the domain is a security for prisons, which is I assist the engineers to do the system integrations. Actually, I work as a contract before I further my study in UTM. And then after graduate, 2005, I'm working with the Guthrie. This one is under plantations. This company now is merged with the SIMW. I'm focusing on the system and networks. And then 2007, I'm start working in the telecommunication domains under the SS network. This one is focused on the IP DSLAM broadband, which is ADSL2 plus. After a year, then I moved to Huawei. This one I under the global team, which is I need to support for the worldwide, which is on site, focusing on the mobile packet core network. 6 years I'm working in Huawei, and then I jumped to Nokia under Center of Excellence, which is they are focusing more uh, on the three major portfolio, which is mobile backbone network, cloud, IMS, IP planning. IP planning for the cloud infrastructure. After I believe around 5 years, and then I moved to Microsoft last year. This one is under the professional service, which is I need to handle for the voice call. Then 2021 April, I joined Sandvine for the APAC regions. This one I need to handle for the VAS services. VAS actually is a value-added services for the network analytic. Okay, if you see on this picture below here, these are all operators that I working since 2007. There are 3 local operators that I've done, Maxis, Celcom, DG, and then they are working with the VTR. VTR actually in Chile. I was there, and then they are Nepal. SL is from India. Then Nextel, United States. Then some in Europe, for example, in Vodafone's, Orange. Then there are Central America, ICE. Indonesia as well, Axiata. Some of the work I working on support, some of work I working on the design. I mean, design, the fundamental design until the rollout, especially for the Telkomsel, I believe. Yeah, Telkomsel here. Actually, I'm staying in Telkomsel for the 3 years. I'm developed start from 2G, 3G, and 4G for the Telkomsel here. Now, when in Sandvines, I focus only one operator, which is Telkom Indonesia, PT Telkom. Okay, this what that I received since my working in the telecommunications, which I got recognized from the Huawei Argentina Indonesia, then under the COE, what I've done for the project. Okay, let's move on the first slide for these presentations. This one I will focus on the mobile architecture 4G and 5G. Actually, I want to give some briefing about how the 4G networks, how the architecture for the 5G. At least if I go for the details on the next presentation, at least everyone here will get some ideas how 4G networks architecture, and then how we mapping to the 5G networks. Okay, this one is a end-to-end. If you see the network architecture here from the radio sites, okay, we can see there are front hall here, and then there are all the access network we can see from here. And then we have the IP network at this stage, IP edge, and then we have the BRAS communication on this. We have the L3 provider edge. This one more on the datacom side, but from the mobile backbones, they are focusing on this level. So the components inside for the 4G network actually is a MME, SP gateway. These are main core elements for the 4G network. Okay, when we move to the 5G networks, we can see on the radio sites also is a same as a 4G, only the interface later on we will see how the interface will show on the network topologies, and then we can see some elements will connect to the 5G core like IMS. This one is a packet data network, and then there are some elements inside the 5G core. They will have a SMF, AMF, UPF, these kind of things. Okay, there are some main difference between the 4G and 5G. Okay, why we required 5G? Okay, if we look back on the 4G, we have the APN that we store in our handphones. We have the APN, for example, I give an example like operating DG. Okay, we have the APN DG, and then for this one, we normally when we develop for the 4G at that time, we use one at the APN, and then from the core network we were splicing with the multiple services like MMS is like another services from the other parties. So from the core system will differentiate all the APN. Only the user only see the single APN, but on the 5G, the methodology is a difference because we are using the slicing. So on the slicing type, on the even though on the radio we have the SST mode, which is we have to define SST 1, 2, 3, 4, because in the 5G there are three major elements like broadbands. We have the IoT. We also have another uh, another slicing. For example, the vehicles. This one is another release. We will talk later. And then if we check on the platform itself, normally for the start for the 4G, we already introduced the platform for the clouds. And then for the 5G, we will continue on cloud platforms. Some of the operators are using the private cloud, public cloud, or hybrid cloud. Hybrid cloud actually is a combination with the public and private clouds. Okay. Before we move on the 5G, there are some principles that we have to put in mind. Okay, for example, before we have the control plane and user plane in one interface, but in order to prepare for the 5G, so in the 4G we already split. This one is we call CUPS, control user plane separations, data plane and control plane. All the signaling will go to the control plane, and the user plane will go to the data planes. Why? Because we don't want any signaling inside the data plane, and then we want to make it fast. Because in the broadband, we want to reduce the latency. This is a goal, and then we need more bandwidth. This like for the network slicing, how the individual network slice for the different needs. different requirements or will have the different slice. Okay, this is a detailed component for the 4G and also for the 5G. If we check here, when we talk about the mobile core network, the elements inside for this actually is a MME, SGW, and PGW. And then there are additional connectivity, which is a PCRF. We also have the OCS, HSS, actually keep the registration on the subscriber profiles. And also we also have the AAA for the authentications. And then their interface, if we check here, all the LTE, they are using the S1U, S11, SCA. But on the 5G, okay, here from the 4G, we call MME, but in the 5G, we call AMF. But on the, there's some combinations between the SMF also. And then on the UPF, it's like a SGW and PGW here, UPF here. That's why we can see the gateway user plane here. And then in order to talk here, there are separations, there are another interface to communicate with the control and user plane. And then for the IoT, we have additional components, which is in the 5G, they call NEF, but in the 4G, we call SCEF. Service contact exposure functions. This one, the purpose for this element is like a gateway for outsider on the develop for the IoT applications, able to extract the API and then comes to the MNO, mobile network operators. This one, we consider all these elements inside the mobile network operators here. And then after the NEF, we have multiple, multi providers will provide the IoT solutions. Another thing is difference about the concepts. In the 4G, we use the APN. APN, we will store, write in our handphones what's the APN name. But in the 5G, they call the DDN. This is another different terminology between the 4G and 5G. Okay, now we start on the NB-IoT. Okay, before that, I just want to give some brief about this IoT. This one of it is a cellular IoT. Why actually, if we check on the internet, the devices connected to the networks now, we are actually in future for 2021 will be around 25 to 30 billions were connected to the network. And then we can see how they do some analysis on the M2M, consumer electronic, non-cellular, and then the PC, laptop, mobile phones, fixed phones, and then there are some use case that we use on the NB-IoT, which we can use the vehicle telematics, agriculture tracking, smart meterings, energy. What is it? Actually, this one not all will use NB-IoT. Some will use the LTEM. Some will use the CIoT. It's a different NB-IoT and CIoT. And then if we check, for example, here, we have the Wi-Fi, we have the Bluetooth, we have the Zigbee. ZigBee actually for this one actually is a non-cellular solutions. There are a lot in the markets using the ZigBee for the IoT. This one is a non-cellular solutions. Okay. For the NB-IoT, this one I focusing on the 3GPP release 13 because in that for NB-IoT there are another two more release, which is release 14 and release 15. But normally in our mostly on the markets, most providers using the release 13. Okay, if we check the specifications, NB-IoT, what we need for the NB-IoT, first we need to improve the door coverage, and then we also need to have the low throughput devices, low delay sensitivity, and also we need a chip for the device. And the main thing is we need low power consumptions. These are what the main focus that we need. Because normally for the NB-IoT, we require the battery can hold around 10 years for this one. And then for the throughput, this one not used much for the throughputs, but for the latency, actually they are defined less than 10 seconds for the uplink. And then we can see here, we have the CAT-M, we have the NB-IoT. Later, I will show you in Malaysia, we have only the NB-IoT, not the CAT-M. And then on the RAN sites, in order to support the NB-IoT, we can reuse the LTE antenna, but only we need to have the baseband in order to support NB-IoT. And also we need to increase the number of sessions. And then on the cost side, actually these are my major domains. We will support the RAN paging efficiency, and then we will use how to use the efficiency on CIoT core network architecture, and then another one is a streamline of the control data delivery. This one purposely to reduce the signaling load. Okay, on the specifications that I mentioned before, this one I just do the summary. How the extended coverage and distance for this one is on the theoreticals. Actually, we can get the 22 kilometer from the cells. I mean, from the tower side, we can get the 22 kilometers. But the practical that I've done before, normally we will receive around 18 to 20 kilometers. But it depends on the coverage. This one. And then the frequency, actually there are a lot of band or the frequency that normally we use the 700, 800, 900 megahertz. And then the bandwidth for this one is between 180 to 200K. Okay, when we talk about the capacity number of connections per cells, we support the 50K connections, and then it support 40 devices per household. And then on the power consumption, as I said, normally we will need to use the battery life up to 10 years. And then this latency, less than 10 seconds for the uplink. Normally the data rate is 200 kilobit per second. And then the transmit power is, we have only two choices, plus 20 dBm or 23 dBm. Okay, there are some advantage and disadvantage using the NB-IoT. As a PM Liza mentioned before about the LoRa and Sigfox, this one is considered non-cellular technologies. NB-IoT is a cellular technologies because LoRa and Sigfox is an unlicensed low power wide area. So if you consider on the unlicensed, you can go for the LoRa Sigfox solutions. But for the NB-IoT, we require the license to apply this. And then it also will offer the long battery life because of the low power consumptions for usage. And then if we compare to the GSM or GPRS, this one is considered for the 2G systems. The coverage is wide. And then most of the operators, actually in Malaysia, only Maxis have a NB-IoT license. We can check from the GSMA website, then we can see all the whole operator in the world have a license for the NB-IoT or the LTEM. Actually, we don't have that LTEM spectrum for this. The disadvantage for this, okay, NB-IoT actually not support the voice over LTE, because that's why NB-IoT focus on the stationary. If you want to place the device, only the station, is not about the mobiles. Mobile more focus on the another one called LTEM that I show in the previous slides, but we don't have this kind of license in Malaysia. And then for the roaming, last I've done on the NB-IoT is not support for the roaming. Maybe now it will actually we can use the roaming methods, but previous 2014 when I applied for the NB-IoT, still not support for the roaming features. Okay. This one more on deep technicals. Okay, if we check here, we have defined S, G, and I. S actually stands for standalone for the GSM. G is a guide band. I is the in band. Okay, there are differentiates for this one. If we check here, between LTE, we have a 200 kilohertz here. This one we call guide band. And then for the in-band, inside the LTE coverage, we have 200 kilohertz using on these parts. But GSM is a difference. You can see here on the standalone side. And then the battery, I'll give one example here. Let's say the reporting interval we required every 2 hours. And then the download packet size is 65 bytes. And then uploading packet, this one considered 200 bytes. Download is 65, 200 bytes. And then we go to, let's say for the in band, for example, in band here. Okay, this one we can see coupling loss. Let's say 144 dB. The battery life is 20 hours. If we go to 154 dB coupling loss, it will reduce 7.7. If we go to 164 dB, he will reduce 1.3 years only. But the theoretical that normally IoT, they will use another parameters to get 10 years for the battery life. These are only the reference when we develop our use case on the NB-IoT. Okay. For the deployments, we also set the minimum deployments for these features. For example, normally in the radio, there are two concepts actually we have to look in details. For example, the DRX and also the PSM. E stands for the enhanced DRX, the PSM. Actually, the PSM, there are some timers play for this uh, uh, for this network, which is if you check on the tau period, because when we talk about the tau period, this one focusing on the 4G, but when we talk about the RAW period, this one is for the 3G, RAU. DAU is a tracking area updates. RAU is a routing area updates. Because we have the timer to play around with the PSM, for the DRX cycle, we have already fixed the cycle for this one. We can when we want to do the tunings from the both side, we need to ensure. That's why here he mentions about if PSM DRS timer was set differently in different network devices, and service behavior will change and impacting their responsiveness to back-end originating commands and the longevity of the batteries. That's why during the tuning, we have to consider many things in order to get the battery life longer. And then we can see there are some features, if we not enable inside the core network, we can see there are a lot of negative implication end-to-end security, because this one is inside. Okay, and thank you. Okay, if we have here in a mobile architecture, we also concerned about the end-to-end security. So that's why some NB-IoT features should enable in order to use the end-to-end security. If not, our design for the NB, people can simply get to your network. And then in the earlier, I mentioned something about the SEF. In the 5G, we call NEF. This one actually for provider IoT to develop and then to use the API benefit from the operator sides. And then on the last one, roaming devices. Okay, when we talk about to get the certificate for the all bands, because this one need to have an agreement between operator local and also the roaming operators, the visitor operators. We need to see how the cost implication using for this one. Okay, when we talk about the use case here, we can use the NB-IoT for the different use case for the smart agriculture, smart parking, smart grid manufacturing automation, smart home automations. Even though currently I also have developed smart home application, but I'm not using the NB-IoT. I'm using the ZigBee. So this one is a non-cellular for the smart home. I can control my appliance via the internet. So in previous project that I've done, I'm using the NB-IoT for the smart parking. This one, if I'm not mistaken, the project is Romania. We use this concept, I believe around 2013. We developed the project for the smart parking for the Vodafone's operators. Okay, this is a summary that I stated in the previous slides. The bandwidth, the coverage, and then the battery life, and then the low power, and then we have some cases using the PSM, some cases using the DRS. It depends on the case, the use case, what we want to use. And then the latency is less than 10 seconds for the uplink. Okay, when we talk about the NB-IoT architecture for the 4G and 5G, as I mentioned earlier, MME. But for the 5G, this one is considered AMF or SMF. SCEF, as I mentioned, this one is exposed to the outsider. We call it SCEF. But for the 5G, we are using the NEF. But on the P gateway, PS gateway, this one is user plane from the radio sites to the S gateway, and then from the S gateway go to the P gateway. Okay, from this part we will have multiple S gateway here. Some will go to A, someone go to B, someone go to the C, and then from S gateway we can select which P gateway we want to go. P gateway actually will connect to the multi provider for the PDN internet or so on. Here for the 5G, we call this one is a UPF. Actually, this one is already simplified with the big architecture, because normally in the architecture we should have the charging, we should have the HSS to keep the subscriber profiles. We also have the PCRF, we also have the OCS, but we try to simplify in for this form. Okay, on the NB-IoT, not all application using the IPs, some non-IP data. So we can see, for example, this use case for the meters. Okay, all the traffic goes to the MME. This one is considered for the signaling here. He will go to S gateway, P gateway, and go to the applications. This one S11U, this one is a connection for the user plane. How the traffic go to the MME, S gateway, P gateway, and then go to IoT applications. And then if you see here, transmission frequency is very infrequent. We're not sending the transmission frequently for this one. And then for the connection setup rate also very low. This one is for the meters. If you want to get the meter to read the meter from online and so on, sometimes they will push. He will provide all the informations via the traffic flow. Okay, this NB-IoT consider on the non-IP data. Okay, the difference is only on the PGW and also in the IoT application. This one we consider as servers. We need to have the tunnel between PGW here and IoT servers. This is only the difference. We have to set up the tunnels in order the non-IP data flows to this flow traffic. Okay, there's some features which is inside the core network, which is inside the MME features, which is sometimes we require the high latency communications. Most of the vendors have this feature because we follow the 3GPP requirements, which is we need high latency. The purposely is to handle empty communication when UE is a PSM or EDRS. Okay, actually there are a lot of they are required to have this because we need to refer during the initial response time before the normal exchange of packets is established. Actually, he need UE to wake up from the power saving states and respond to the initial downlink packets. That's why we require high latency, high delay for this one. And then we can see PGW also indicate to the MME, which is PDN session, are delay tolerance. Okay, this one is a different DDN. This DDN that I mentioned earlier, this one is similar like APN. For this one is different, which is data and power is a aggregate. To understand this, in order to receive the SGW for one delay tolerance PDN sessions. And then we can see for the MME mark that the UE also have a pending data and the pages to UE as the next paging occasion. Let's say NB-IoT in the idle states. So we need a core network, send the paging, and then ask the NB-IoT UE to wake up. This one a paging come in this place. If not, because in order to have the power consumptions, to maximize the power, to maximize the power save, so on, NB-IoT UE, this one, actually NB-IoT for access, he will, we can see like it will shut down, he will terminate the links because UE not sending any data. So he will make the NB-IoT UE in the ideal states. But the subscribers still keep in the MME. Only when the data required for this one, so the paging should send back to the UE in order UE to wake up and then send the data to the uplink for this flow. Okay, this another features that DCN, dedicated core network. We can see some operator, their capability to deploy the multi-dedicated core network DCN within the PLMN. Actually, this also can deploy the NB-IoT, and then we can see how DCN can conceive with multiple MME, multiple S gateway, and also multiple the P gateway. And then we can see also how we can deploy the very specific type of the subscribers, because we need to sure some of the subscriber, this one is a IoT devices, some is a specific enterprise subscriber, some is a, we need to isolate the specific subscriber, that based on the cases, use case. And then there are details here on the parameters AVP for UE usage types. This one is a selection of the DCN. And then if need to know in details, you can open up the 3GBP document 23401. Okay, for the document here, if you open the 23401, 4 is 10 for the 4G, 3 for the 3G, 5 is a 5G. So if you want to go on the 5G, you have to open to 3.501. These are some tips if you want to dig on the documents. Okay, this is an example in Malaysia, operator in Maxis. Only one have this coverage. If we check here, the blue colors here, all is a NB-IoT. I mean, we have this spectrum, only NB-IoT. We don't have any spectrum, the LTE-M. Only there's some countries here and in other regions have both. They have the both spectrum LTM and NB-IoT here. And then in Maxis, they are available in Cyberjaya, Penang. Actually, for this one, you can open up the website GSMA. The detail you can see who's the operator have this kind of license. Okay, now we forward to the 5G. Okay, in our for the 5G concept for the market that we need to snapshots. We need to cater for the broadband evolutions. We need to have the Internet of Things. We also need to have the machine to machines for this, and then critical machine communication. They are more focused on the latencies. This one required the high bandwidth, and then this machine to machines. We also need this one is like NB-IoT for this part. And then we also have an additional release, which is this one for vehicle, VCS. This one focus on the another release, but I believe this release is a release 15. But if you go to release 16, 17, and 18, you can see the VCS inside the SST mode. Okay, this is a roadmap for the 5G. If we check here, actually we start for the 5G since start from the 2016. But this one, the components, we use the APN as for the base slicing, but it's not the real one. We use the single APN, but from the core network, he was spliced with the mapping from the UE and then to the core network based on the parameters. And then we also have the automation deployment or the start for this, because this one already start on the cloud scalability on this. And then we check on the roadmap 2018-2021, you can see the difference. They introduce a lot of the features on the network slicing, the QoS, because the QoS we will use the flow QoS, and then we have the user plane and control plane split for this, and then we have the UP relocation. Actually, this one is a UPF. We will put all the UPF in the edge network. It's not only the inside the central one. We will put the UPF like MEC to the edge network for the nearer one, because we want to get the we want to reduce the latency on this. And then we already introduced the microservice architecture. This one apply in the IT on the IT architecture. They will apply the this concept to the telco architecture. Okay, these are some of the 5G use case that we can use based on needs. For example, currently we have the enhanced mobile broadband because we required high speeds, and this one required for the always on, always connected internet links with the real-time responsiveness. Okay, so we also need have M2M. This one machine to machine type communications, and then all the embedded sensors able to connect for this here. And then we need to scale down the data rates, power, mobility to mobile extremely lean and low cost solution. This one is we consider the NB-IoT. But for the mission of the critical, this one is as I mentioned, for the 5G vehicle subscriptions. Okay, this is very critical. We need care about the latency. That's why for this part, we require around 1 millisecond for the low latency in order to have, because we have distance between one car to another car is about 3 meters, if I'm not mistaken. There are some rules to develop on this. before he stop and then do the emergency brake for this one. And then we have for the gaming also here is quite huge. All the giant gaming providers required very very uh, need a very high speed on these in order to process the graphics, image, and audio. Okay, some information I repeat in the previous slide, but what I need to focus is the technical requirements. Here, you can check all these. For example, you want to go to the network operations, go to these documents. You want to go to the enhanced mobile broadband, you can go to the 863, and then you want to go to MSc MTC, you have to go to these documents. Okay. I try to simplify for this because there are a lot of when we talk about the 5G coverage here. When we talk only the 5G coverage, we didn't see all the MME. He will go to the AMF, the SMF, and then go to PCRF. This one is a considered. This one is a PCRF. All the provisionings will have inside the PCRF, and then the rules to apply, to deny, or to reject the subscription also from the PCRF, and then here also can communicate to the IMS for this. If you go for the 4G users, he will go to the MME, S gateway, P gateway, and then there are some DRA connected to the PCRF and so on. This one is to understand details here, need to understand the mobile architecture. And then when we talk about the 5G technologies, actually it's a similar that I show in the previous slide. Only the term here is a difference because in the HSS for the 5G we are using the UDM HSS, but for the 4G we are using the HSS here. And then we also have the SA, the 5G SA. Also we have the FG NSA, non service NSA. Actually, last time the project that I've done in Rakuten, Japan, at the time 2019, I was used the F5G NSA option 3X. For those know about this, I believe they have some ideas what I'm saying about the 5G NSA option 3X.
Raja, please, Raja.
Yeah.
I think we have about 5 minutes left.
Okay. I try to speed up.
Yeah, thank you.
Okay. On the 5G, we are using the SBA architecture. All the connection using the HTTP for this one, and then NRF actually functioning to communicate all these nodes elements. And then for the judging, we are using the HTTPS for this. And then this how the network functioning, register, and discovery. We need to send registration to NRF, and then NRF need to discover what's the elements he need to search, and then he will point in the record on the delivery sites. It's similar to SMF functions. Here, these are details how it work. And then this one is a online and offline charging. In order to have the complete setup, we should have the online or offline. Let's say we have the prepaid or we have the postpaid sites. This is how we play with the architecture here. And then we can see how it's comply to this 3GPP, the 3GPP for the versions and also the release one. And this one is a QoS designs. In order to have the real setup, we need to apply all these we need to apply all the QoS profile to between the UE and the in the network, and also the UPF also have the QoS for this. Is detail for the QoS designs. You can refer it later. Okay, this backup slides. Actually, this one I want to show how NB-IoT working on the roaming side, because HP element is a local. For example, this in Malaysia, this one actually maybe in our neighbor country is Singapore, for example. The UE, we can plug in the UE here. Let's say our SIM cards go to the Singapore, for example, here. We can install here, and then we can go back to our country to use the application for IoT. This one is a platform actually for the 5G cloud native. For the 5G, we are using the SPA architecture. And then you can see here also how the standards, the Asia Pacific defines the frequency spectrum. You can check in detail from the GSMA website. Okay, these are all documents that I highlight here. You can refer to these documents, because all the specific requirements for every interface or every single features, we have to look into deep documents. This is a appendix for the duplex modes. And also we have the downlink, and then there's a band B1 or B66, and then based on the release here. And then this actually this report I will share later to our coordinator. Okay, now almost 11 o'clock.
Yeah, right on time. Nice. Good timing.
All right.
Okay, all right. So thank you very much, Technologist Raja Muhalli. So we go into the question and answer mode. So let me, if you can stop sharing, I would like to share the slides of the questions. Okay, I have already compiled, but that is based on what I have in the chat box. So I'm not sure whether we have any questions from the FB Live. Okay, so for now, okay, let me share screen. I hope I get everything. Okay, all right. Oh, this is not the one. Okay, hold on for a while. Okay. All right. Okay, can everybody read what I have right now, the question and answers? Okay, they are altogether about 12, I think 12 or 13. So maybe I can go on one by one with you, Raja Muhalli.
Okay.
Okay, starting with the first one, is the CIoT same as NB-IoT? I'm sorry about those, I did not put in the names, but I'm sure in the chat box you know who posed that question. Okay.
Okay. Actually, there are a lot of arguments in the forums. In the previous presentation, I mentioned something about the cellular network and also non-cellular. Okay. CIoT is a cellular IoT. And then I mentioned NB-IoT is a cellular. But if we go in deep on the parameter and setting, that one's actually totally different. It's a part of the CIoT, but actually it's different. Later I will share the forums that argue about this terminology on this. For question 2.
Okay, all right. For question 2, for battery to last 10 years, what is the signal strength required from the base station to the NB-IoT device?
Okay, that's why I provide the guidelines in the previous slides. Actually, it depends the parameter setting. And then you can try to map For example, if we required for 2 hours to reports, and then we have to set also the coverage for example, 164 dB, for example, and then we also need to define another parameters like the payload for the downlink and then payload on the uplink, whether this one is a 50 or 200, this kind of things. You can refer back to my slides later.
So with this, if I may, considering the signal strength, okay, from your slides, the NB-IoT device can go up to 22 kilometers. Okay, that's
Yeah, correct. This is a theoretical.
theoretical. Okay, so in this case, for battery to last more, we have the device in close proximity nearer to the NB-IoT Node B or your base station, right?
Yes, correct.
All right, okay. Thank you. So the next question, I do not know, maybe some clarification. You mentioned about Maxis offering NB-IoT. So this statement says that to his knowledge, to her knowledge, Huawei is also serve NB-IoT and currently serving iSlango for smart water metering and also Celcom. Can you
Okay.
clarify this?
Actually, from the GSMA, actually I got all the information from GSMA. Actually, GSMA actually they provide all the whole operator around the world. Actually, he only mentioned about Maxis. He not mentioned about Celcom. He not mentioned about the VB. Maybe this one need to check on the MCMC because all the spectrum actually we have to get from the MCMC actually.
Okay, all right. Okay, so question number 4, what is the expected degradation to existing LTE users when in-band mode is used?
Okay, wait. Okay, in band. Okay, means inside the LTE the coverage. This one more on the radio side. In details, I can't explain in detail because I'm not from the radio. In first place, I'm not from the radio. My background is from the core parts. I believe the degradations can how to show the slide. I want to show the tables. Is it possible I share again?
Okay, yeah, I will stop sharing. You can share now, Raja Muhalli.
Okay, wait. Share. Okay. When we talk about the in-band, the question is about the in-band, how's the degradations. When we talk this coupling loss, if we go less the coupling loss, for example, I here. If we go, I talk more on the cost perspective, but in detail on the radio sites, there are a lot of parameters will contribute on degradations. I can come up with a real technical one, but impact here, if we check, if we use the for the upload for the 200 bytes, for example, for the uplink, we can see for the in-band 144 dB coupling loss, he can constant on the 20 hours for the battery life. But if we go to deep the coupling loss, you can see he will reduce until 1.3 hours only here. Because of the coupling loss affected. This is one of the contribution. That's why it depends on how you set up the network. This is only reference.
Okay, thank you.
Okay, let me stop the sharing.
Stop sharing.
And, okay.
Okay. Let me get into my point. Okay, all right. So the next question is, what's the difference between the two battery types that you mentioned in your slide? Oh,
Two battery
yeah, two
types.
battery types. The two types of batteries that you mentioned.
Okay.
You say about the PSM or DRS?
Yes, that one.
This one, this one is not battery.
So what are those?
Okay, this one is to make the antenna to read is it actually is what is a method to control the power consumption. Let's say we have the UE, we have the tower here, the cell. We can say about cells. If the connections keep established, is it the power comes? Is it the battery life can keep longer? No, right? Because suddenly still keep communications. That's why the method for the PSM or DRS come into this place to control, to control, to control the UE become to the ideal or stop for this one. So the signaling can say there are no establishment between the UE and also the cells. They will stop signaling communications until the timer comes. That's why the when we talk about PSM, there are two type of timer. When we talk about the 3G, this RAU, routing area updates, or 4G, they call TAU, tracking area updates. This timer is play in the PSM modes. But when we go to DRS, there are DRS cycles can use. Uh, uh, Actually, they already fits the cycles the numbers actually. We cannot set up by ourselves. They already have a 1 2 2 6 5 if you are not mistaken. Their range on this. They are already have a calculations. These are different. Sometimes the case using the PSM, sometimes the case using the DRS to save the power consumptions.
Okay. Right. Okay, that answer your question, Dr. Ruzi?
Okay, I think maybe they are actually energy scheduling, like, or the timing, I guess, like what time should be idle, what time should be active.
Yes, correct.
Yeah. Okay.
Yes,
Right.
that's why
Okay.
mention about the timers. All right.
Yeah. Okay. Thank you.
Okay. So next question is, which 5G spectrum can NB-IoT be used?
5G spectrum. Even though now MCMC cannot publish, so for this region, I don't know yet. Because now 5G is under the DNB, Digital National Berhad, is a control all the 5G. Not other operator can control this. We are waiting the MCMC to publish this.
Okay. Isn't it using the sub 1 gig bandwidth, the 700, 800, and 900?
Actually, based on this, because this already defined from the GSMA for all around the world, this 700, 800, they are already defined the band. But which band, I'm not sure.
Okay. All right. Specifically, we have not
Yes.
MCMC has not come out with the distribution of the spectrum. All right.
Yes, correct.
Okay. All right. Next question. Uh-oh. I'm
Is
trying
there
to.
any?
Okay. What are examples of non-IP data?
Okay. If we talk about the sensors like pH, this one is not digital, it's an analog.
Oh,
So if we talk about the switch, we have a 0 and 1. Even though the electric on the electric one, if you achieve to one threshold, for example 0 point something, this consider zero logic. If this one consider maybe the 5 volts or 3 volts is considered one logics. This one is consider all the non-IP data.
Okay. Right. I think that answered the question. Can I proceed? I proceed with question 8, which is recommended NB-IoT to have a dedicated S1 towards core or to have a shared S1 for NB-IoT together with commercial LTE users.
Which are recommended NB-IoT to have dedicated S1 to share S1. Okay. On the commercial. Okay. If we check here, one cells, we can have the 50K connections. It depends on the, let's say, if we deploy in the commercials one, we have to define how many connection that we required. Let's say if less than 50K, actually normally the operator will ask this question first. Let's say you have the 2 or 3 providers, and then one connection maybe from the A side only have 10K. I'm sure they will share this. It's not simply they open another cells. These are common in the planning side from the operator.
So meaning the concept of sharing is there for NB-IoT, okay?
Yes.
So through the okay, for the A side, meaning in this case you will have for agriculture. I think you mentioned about smart marking. I'm sure there are many sensitive data that you get for each parking bay. So you need to have maybe you have to sort of group everything, okay, into one non-IP data and you transmit to the cloud.
Yeah, only the difference is they use the APN.
Okay.
APN. Okay, for example, A they have APN 1, B they have the APN 2, but on the radio side, I'm sure they're sharing this.
Okay. All right. Okay, question 9. The study shows that 75 hertz effect to human body. So recent technology using 5 gig, which shows using 5 gig. So do any precautions measure implemented while developing any system? So how
Okay,
to validation? Yeah.
I can't answer this because I'm not from the radio.
All right.
Uh,
So many from where we have read, there is no, I don't know, there is no significant effect, but well, we need to do a lot of reading. Okay.
yeah.
All right. Question 10 is why LTEM is not popular in our region compared to Europe, Australia, for example?
Okay, actually, when I was in Europe, we have the regulatory there. They already defines why they require this and this because on their test case because they require the mobility. But in our case, we need to check on the MCMC. Why? This because it's based on how they deal with the uh, major major part to get the spectrum. Why on the Asian, not focus on the LTM.
Right.
But in Europe, they're developing so fast. 2013, they already developed this. When I was in Romania, they already developed the smart parking.
Okay. So, all right. So I think that answered the question. Question 11, may I know what is the best open source tool to run the simulation in IoT simulation?
Open source tool to run the simulations. Actually, all the vendors have their own simulation tools, but this not published to public because of we need to simulate uh, the requirement from the customers in order to check how many our system able to support. But on the source tools, I believe that you can check from the GitHub. There are a lot they share on this. But from my side, we on the vendor point of view, we have these tools because of the R&D. Because we have a R&D team develop this tool in order to run based on the telco requirements or the sales requirements.
Okay, so last question that I have right now. Are there any commercially deployed NB-IoT over 5G? If yes, which spectrum? Okay, the same question with what we have just now. SA or non-SA, I mean standalone or non-standalone, and which are the use cases, if you can mention some?
Okay, when we talk about the NB-IoT over 5G, okay, there are in the earlier my presentations, there are two things. You want mention about 5G core or 5G on the radio sites. This is a one. NB-IoT is a if NB-IoT over the radio site 5G. Yeah, I didn't see this yet, but I believe on the theoretical, yes, can. As long the baseband is changed based on the NB-IoT narrowband frequencies inside the 5G SS 5G SS network. But for the core side, this is support. And then SA or NSA, okay. Which use case? Okay. 2019 already developed the NSA actually. There are a lot of options. There are option 1 until option 8. But normally in the forums, and then all the operators around the world agree using the option 3S, because this one is practicality is good to use. But before SA come to the place, because at that time SA not ready on the radio sites, but now looks like for example, we can see in M1, for example, in Sintel, they already have the SA apply for the, I'm not sure about the commercials, but they all have the trial site for the SA.
All right. Okay. So, Key, do you have, I'm not sure about FB Live, but there's no communication from me, no information that we have any questions from FB Live. So I would allow only one single question if that you need to ask, okay, before we go into, we end this talk? No? All right. Okay, so I think right now, okay, I will stop sharing. Okay, I would like, in this case, we have come to the end of our industrial talk, and I would like to mention my gratitude, our gratitude, UBAN and the IMS, okay, for two Raja Technology Saja Muhalli to give us a very good talk. Okay, many things that we have learned, and hopefully it will assist us in what, because NB-IoT, when you have massive IoT, you need to know what is NB-IoT. So with that, I thank you very much. And from here to, I would like to pass, because we're going to do some photo session. So I would like to invite all attendees to switch on your video so that we will take a group photo. I pass to Dr. Hazilah.
Yeah, okay. We will have a photo session. So get ready, everyone.
Go on.
Okay, for the first screen. Okay, I'm waiting. Okay, 1, 2, 3. For another page.
1, 2, 3. So another page, we have the third page. And maybe the last page. Okay, that's all.
Right.
Okay, thank you very much. And I would like to remind of all, make sure that you have key in your registration so that we can send e-certificates, okay, e-certificates, and also CPD points for UTM staff. So with that, I thank you very much for your time to attend our talk, industrial talk, and hopefully we intend to have more collaboration between our groups, IMS, and also Sandvine Technologies. So we hope that I think that is right? Our head is Dr. Ruzi. That's what she intends, and we have the IMS chair is Dr. Rubia. So we hope that we will have that collaboration in the future. So with
Okay.
that, thank you very much, and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thanks, PM Liza.
Okay, thank you.